All right, so lesson one was all about Calc 1 review, and so we kick off our video series with lesson two. Lesson two looks at something that you should be familiar with from high school work. We're going to take a look at inverse functions. We're not going to do anything in this video that you're not familiar with from high school. We will pick it up a notch when we get into class together. But if we don't have this as a foundation, it's going to be just a mess. Why do we start here? We start here because for the next few weeks, we're going to deal with what are called transcendental functions. Transcendental functions. They are functions that are not polynomials. They're not anything we've studied before. They defy algebra, so to speak. We're going to talk about transcendental functions, and to do that, we need to know something about inverse functions for reasons that are just going to be crystal clear really, really soon. If you're familiar with us from AP Calculus, if Calculus is familiar because you took AP Calculus or college calculus when you were in high school, this is review for you. So it's a nice way to start Calc 2. All right. So let's talk about the so-called, whoa, sorry about that. Let's talk about one-to-one functions. What makes a function one-to-one? And just like in high school, a function f of x is one-to-one on some domain D if f of x1 is not equal to f of x2 whenever x1 is not equal to x2 in the domain. This is a definition of something you are familiar with from your high school work, one-to-one. If you give me two different x's, you get two different y's. That's the whole idea behind one-to-one. If the x's are different, the y's are different. And and so I've got three quick examples, three quick pictures. So if you want to call this example one, you can. Three quick pictures of functions that you may or may not have seen before. And so the question is, which of these are one-to-one, if any at all? Are these one-to-one? So pause the video, read the definitions, think to yourself which ones of these are one-to-one. If you pause the video, great. If not, well, I don't know what to tell you. The red function is one-to-one. Every time two x's are different, the y's are different. Every time two x's are different, the y's are different. Every time two x's are different, the y's are different. This function is one-to-one. The green function is one-to-one. Every time two x's are different, the y's are different. This function, the purple function, is not one-to-one. How do we know? Because these are two different x values with the same y value. And because these are two different x values with the same y value, this function is not one-to-one. So the way your high school teacher may have explained this to you is we imagine a horizontal line, and then we run that horizontal line up and down through the range of the function. And if the horizontal line ever hits the function twice, then we say it is not one-to-one. It's a test for not one-to-oneness. And it's based on this idea that if the x's are different, the y's have to be different for the function to be one-to-one. Well, why do we care about one-to-one functions? We care about one-to-one functions because we care about inverse functions. We care a lot about them. And to talk about inverse functions, we have to have a one-to-one function. So let's suppose that f is one-to-one on some domain D and some range R. The inverse function, which is abbreviated f inverse, is defined by f inverse of b is a if f of a equals b. And this is the sort of thing that you would have remembered from high school. In high school, we would have talked about swapping x and y. That would have been the nomenclature in your high school, that we swap the inputs and the outputs, and that gives us an inverse function. I'm going to do a quick warning here. Warning, 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 warning. This is not 1 over f of x. You were trained from the time you were young that if you see a -1 exponent, it means that that's a reciprocal. That is not true. It just happens that two different mathematical ideas use the same notation. It's frustrating, but it is what it is. This is an inverse function notation. I'll flesh this out for us. You can call this example 2 if you like. So the purple function passes through -2, 0, and 0, 2, and 4, 4. This is the function f, and I'd like to get a sense of what the inverse function looks like. To get a sense of what the inverse function looks like, we swap the x's and the y's. So if -2, 0 is on the graph of f, 0, -2 is on the graph of f inverse. If 0, 2 is on the graph of f, then 2, 0 is on the graph of f inverse. And if 4, 4 is on the graph of f, then 4, 4 is on the graph of f inverse, and you get this sort of phenomenon like so. This is the f inverse graph. You and I probably know that there is symmetry in the picture. A function and its inverse are symmetrical about y equals x. That's a Canadian about for those of you who want a Canadian about. Can we find inverses algebraically? You betcha. Find f inverse of x if f of x is 3x plus 2 over x minus 5. 3x plus 2 over x minus 5. So, well, what does that mean? That means that the original function is y equals 3x plus 2 over x minus 5, which means the inverse swaps x's and y's. That's what inverses do. They swap x's and y's. So now that we've swapped x and y, we've got to solve for y. So let's do that. Let's solve for y. Now we isolate y. Well, that's tricky because there's two of them. So I'm kind of stuck on what to do. So maybe I'll just do this thing that I remember from high school. Maybe I'll cross multiply and it'll buy me time. Maybe I'll just cross multiply and that'll buy me time. Sure. Well, now I've got a y here and a y here. Well, let's kick everybody to the left side. Let's kick all the y stuff to the left side, and let's kick the non-y stuff to the right side. Well, now maybe I can get y by itself. I can probably get y by itself if I factor. So let's factor. Well, that seems pretty straightforward. So when we solve for y, that will be the inverse function. So the inverse function, f inverse of x, is 2 plus 5x over x minus 3. 2 plus 5x over x minus 3. These are the sorts of things that I expect that you'll be able to do before we gather in class. If you're interested in some extra questions to think about, in volume 1 of our OpenStax Strang Herman textbook that's available in Canvas, in volume 1, you're looking for section 3.7. There are some questions in there that I'm going to ask us to do before the end of our lesson, but you don't have to do anything that involves a derivative because we haven't talked about that. Okay, well, very well. We'll see you in class.